All right, let me ask you something. Have you ever had that feeling of just pure dread when your boss asks for a small change to a big old piece of code? It's that feeling, right? The one every developer knows. You're just staring at a function, and you just know that changing one little thing could cause a whole cascade of bugs across the entire app. Now, in our last explainer on the single responsibility principle, we learned how to make our classes clean and focused. But, well, that's only half the battle. How do we stop them from becoming brittle and, honestly, dangerous to change over time?
The legendary Robert C. Martin actually gives this problem a name: rigidity. It's what we call a design smell, a warning sign that our code is getting fragile and really expensive to maintain. That small change request from your boss, suddenly it's not so small anymore because the code is literally fighting you every step of the way. So, what's the answer? Well, there's a really elegant solution to this problem: the open/closed principle. It's one of the 5 core solid principles, and it's designed specifically to fight that rigidity we were just talking about. But I get it, the official definition, open for extension but closed for modification, can sound a little academic. So what does it really mean when we're writing code? Okay, think about your smartphone. The hardware inside, the processor, the camera, all that stuff is sealed tight. It is closed for modification. There is no way you're going to crack it open and solder on a better camera yourself. But is the phone's functionality stuck? Absolutely not. It is completely open for extension. You can go to the App Store and install literally millions of apps that add brand new features, all without ever touching the phone's core hardware. And that is exactly how our code should be: a stable, reliable core that we never have to modify, but with endless possibilities for adding new features.
So, we want our code to work like a smartphone, a solid core with plug-in features. Awesome. But how do we actually build something like that? Let's dive into a super practical example that I'm pretty sure every developer has run into: calculating shipping costs. So here's the classic before picture. You know this function. We've all written it or seen it. It's just a big, messy if-else-if ladder. If the method is ground, do this. If it's air, do that. You get the idea. Now, it works for now, but it's super rigid. So what happens when the business comes to us and says, "Great news, we're launching drone delivery"? Well, we have to come right back to this exact function, crack it open, and bolt on another else if block. It is not closed for modification. And every single time we modify existing tested code, we risk introducing brand new bugs. It's a trap. So how do we get out of this trap? We can refactor it using a classic design pattern called the strategy pattern. It basically lets us define a family of algorithms and make them interchangeable. First, we're going to define a generic blueprint, an interface, for what a shipping calculation should look like. Then, we create separate little classes for each method: one for ground, one for air, and so on. And finally, the magic step: we update our main function so it only knows about the generic blueprint, not the messy details of any single method. And look at this. The after state it's beautiful. Our main calculate shipping cost function is totally transformed. It has no idea what ground or air shipping even are. All it knows is how to use a generic shipping strategy. So now, when we need to add drone delivery, do we touch this function? Nope, not at all. We simply create a brand new drone shipping class that fits the blueprint. We have extended the system with new functionality without modifying a single line of existing working code. That right there is the open-closed principle in action. And that simple change, it has a massive payoff. This is why this principle is so important. When you follow it, you just slash the risk of breaking things. Your code becomes incredibly flexible and creates this awesome plug-in style architecture where you can add new features safely and easily. Your code stops being rigid and becomes truly adaptive. It's built to welcome change, not to fear it. And for the business, that means future changes are way faster, cheaper, and safer to implement. It's a huge win. You know, when it comes down to it, the open/closed principle is really a fundamental shift in how we think about our job. It's the difference between just writing code that solves today's problem and actually crafting professional, resilient systems that are maintainable and built to last for years. All right, now it's your turn. We have all inherited one of those monstrous if-else chains at some point. So, what's the worst one you've ever had to untangle? Was it dozens, maybe even hundreds of lines long? Share your war stories in the comments below. I would genuinely love to read them. And that's a wrap on the open/closed principle. Next time, we are diving into the Liskov substitution principle. I know, it sounds super academic, but trust me, it's a deceptively simple idea. And if you get it wrong, it can cause some of the most subtle and confusing bugs you will ever encounter. Make sure you subscribe so you don't miss it. Thanks for watching.